Hey everyone, hope you're all doing really good. So I recorded a video a couple of days ago, but thanks to Paul Daniels' stupid f***ing software, the whole entire video got trashed. Reserve your copy now from pldaniels.com. Today, we're working on an iPhone 10 that was sent here for data recovery. Hello, I dropped my phone next to a pool and it cracked on the top right of the phone and then bounced into the pool. Went to Apple to recover the data and they told me it's gone forever. Saw your YouTube video on recovering data and I have hope now. This sounds like it's going to be an easy one because Apple doesn't try hardly anything. So let's have a look at this phone. Right away, it feels as though it has been opened before. Oh yeah, came right open. All right, so at first glance, I can see that we have the liquid damage indicator on the screen tripped. Seriously? Yeah. You see this little sticker here haven't been cut already? This sticker has been cut, and we can tell that this board has had heat used on it already because this is all melted. Now I do see just a smidgen of liquid damage here. We've got some visible liquid here on the flex cable. Okay, so this doesn't exactly look like a phone that was taken to Apple and then sent off for data recovery. This one's going to be an easy one. Oh, Lord. Let's get the board out of this thing. We've already disconnected the battery. I'm going to go ahead and disconnect the rest of the cables here. I know I get flack about using my metal pry tool, but that's just what I use. And no SIM tray, so we'll just push that little latch back out of the way. And then for our final flex cable, that is actually a Wi-Fi antenna cable, and it is up under here. So I like to stick my tweezers up under there and just kind of pull up on it. There we go, that's all the flex cables. Now let's remove the rest of the screws, shall we? I love taking the board out of the iPhone 10. 2, 3. 3 screws, that's all we got here. All right, and then we'll take out our little latch thingy. Make sure our flex cables are folded back. And then this thing should lift right up out of the phone. So now with this board out of the phone, we can see things much more clearly. And one thing that I noticed right away, you know, other than the cut sticker, is that this board is not perfectly lined up on here. And also, gosh, seems like there's a pretty big gap, doesn't it? And down here, in between the board joining layers here, we've got some ball squeezage. I'm not sure if you can see that or not, but that is ball squeezage. So let's go ahead and get this crappy looking sticker off of here. For that, I like to use some alcohol. So we're going to soak this thing down real good. It's actually missing some of it, so it's almost like, I don't know, did they put it back on like this? I don't know. All right, so we'll give that just a moment for the alcohol to soak in, and then we'll grab a hold of it with our tweezers and peel it right on off there. Oh yeah, we've got some big old fat solder balls in there. It looks like this one was actually reballed and then put back together, which I'm really not very happy to see at all. So somebody has already tried more than just the average person would try. And because this board has already been all the way apart and it looks like somebody had their wits about them to actually put new balls on it, we're going to go ahead and hook it up to a power supply and see what the symptoms are. Because if this is like a NAND fault or something, or a full file system, I don't want to spend a bunch of time taking this apart and like screwing with it. So let's go ahead and hook the power supply up and see what we're getting for an initial current draw. We're going to turn the power supply on. Oh, and it's drawing an immediate 3 amps. I've got the current set to 3 amps, and when I turn the supply on, it's dropping down to 1.4 volts and it's continuing to draw 3 amps. So I don't know, maybe this will actually be an easy one, but you know, I got a hunch that the short that's causing this thing to draw so much power is actually going to be caused by their reball job and not by the actual problem. So on this one, being a prior repair attempt, we've actually got to take it apart and do some troubleshooting. So I'm going to place this thing on my board heater. and slide in our latches to hold it down. Now I always like to thread in a screw right here. We're going to use that as a handle. Now I do that to make putting the board back together much easier, because if you can just lift it apart without disturbing any of the solder, you can simply put it back together without disturbing any of the solder. But this one, having been reballed before, I'm sort of losing hope in my ability to be able to do that successfully. So next we're going to turn our heater on. And I've got this thing set to 215 or 219, something like that. So I'm going to let this board heat up for 5, maybe 10 minutes until the temperature on the thermostat thing stabilizes, and then we'll check and see if the balls are molten and then take this thing apart. I'll be right back. I suspect that this board has a short on VDD main from the symptoms. If we look at the board here, I've got VDD main selected, and you can see it is just snuggled right up to ground all over the place. So I suspect that the short could be between the board layers, because if this person was skilled enough to reball the board, they're probably skilled enough to have found a main short. So this thing should be up to temp now. I'm going to start by just kind of touching around the board here to see if it is floated. And it looks to be floated. I always like to turn the board a little bit side to side. Yep, and we've got very much clear moving between the board sections. So let's go ahead and take this board apart. For that, I like to turn my holder and use my curvy tweezers. And I do this so that my tweezers will kind of rest on top of NAND and keep this thing flat as I lift it up off of there. So we're going to just grab a hold of this screw that I put on here to be used as a handle. And we'll just take the board apart. There we go. Now I'm going to look at the bottom board first, because these typically have spacers that I like to try to keep in place, and I always flip them back while the board is still molten. And this reball job actually looks pretty good. We've got one spot over here where I sort of smudged a couple of grounds together. That'll most likely be okay. We'll deal with that later. We've got some Q-tip fuzz in here that is not mine. Some more Q-tip fuzz. You know it's hot whenever it bubbles. Oh, a little bubbly. So the bottom board really isn't looking that bad. Let's see what kind of carnage has been created on the top board. So somebody really has done a good job at reballing this thing. It makes me very concerned that if this was just something as simple as a main short, they most likely would have gotten the data. So this makes me think there's something much more crazy wrong with this thing. And they left fuzz all over it, and ugh. We got an awful lot of ball squeezage going on down here. Hopefully that didn't come out from under that PMIC. Wouldn't that be something? Botch up the PMIC and then send it to Jason to be the mess cleaner, clean up the mess. All right, well, let's check and see where our short actually is. I'm going to go ahead and take some of this thermal compound off of here to try to keep it off of my bench. Okay. So one of the first things I'm going to do here is check VDD main for a short to ground. I'm going to use my multimeter in diode mode. I'm placing my red probe on ground, and we're going to put our black probe on VDD main, and we are getting a 0.31. So this board does not have a short to ground on VDD main. Now I'm going to go ahead and check the bottom board. So we're going to do the same thing, only on the bottom board. I'm going to put my red probe on ground, and for that will just be the shielding on the sim tray. And then I'll put my black probe on VDD main, and we are getting a 0.2. So although this seemed like it should be a simple one because it did have a short to ground on VDD main, that short to ground was actually caused by balls sticking together between their reball job. So let's see what this board does when we try to boot it. For this, I'm going to use my eye socket from Qian Li. And we will place our bottom board just like that. We've got this little riser that's like a spring-loaded thing. It's made to poke through everything. I really should have fixed those two ground balls that were sort of touching together, but that'll be okay. And let's sandwich this thing right on down in here. Now this thing goes in with some force and it sandwiches those two boards together. Okay, there's our touch connector. We're going to hook up our display connector. Now also, keep in mind we did have some visible liquid damage here, which I would normally go after first, but somebody else has already been through this board pretty thoroughly. So right now I'm really just trying to see what it is that caused this to wind up coming to me, because if they could reball the board layers, I think that they probably could have recovered the data. Okay, we're going to hook up our dock flex thingy here. This, we are only using it for boot prompt. Okay, so let's turn the power supply on. It is still drawing 3 amps of current. This might mean that we have a short on something other than VDD main, possibly the battery rail. Let's check the battery rail. Take the power supply off. And instead of checking VDD main, we're just going to check the battery rail. So we'll put our red probe on ground and black probe on our positive battery terminal. Oh baby, there we go, we got 0 ohms. Ha ha ha. So although I set out like this was going to be a classic short on VDD main, this is actually a short on VBAT. Let's look at the board view. So we know from looking at the board view, we have some caps right here in this area. And then we know from looking at the board that we've actually got some some corrosion here in this area. I cannot believe that I just took the board apart for this. This cap here is excruciatingly common to wind up with liquid damage on it, and this cap is excruciatingly common to become shorted. And as you can see, this cap looks like complete total garbage. So we're going to go ahead and get that cap off of the board. Just like that. And now we're going to check VBAT again for a short to ground. We're going to put our red probe on ground, and we're going to put our black probe on VBAT. And now we're getting a 0.36 voltage drop to ground. Now a lot of you watching this channel, a lot of you doing board repairs, right now you already understand my frustration, but what I have just discovered is that I could have actually got rid of this short without taking the board apart. Flick that cap off of there. Let's finish this data recovery. I'm just going to go ahead and touch up a couple of their balls. Nothing too crazy here, just the ones that I accidentally smeared together, because they actually did a really good job reballing this board. I mean, the balls are a little bit big, but I mean, that's going to be perfectly okay. Yeah, I'm not going to do a whole lot of work here to touch this one up. I just want to see that it floats back together and can have working touch. All right, so this is all looking, the balls are looking completely acceptable. Now to put this back together, I'm going to sit the bottom board right back in the holder. And since we're not lifting up on it, I don't have to flip the latches down. Now I'm going to turn the heat on and let this thing get a little bit warm. Now I've got it warmed about halfway up to temp, and I'm going to go ahead and put some fresh flux on here. And I'm not being too terribly picky about the size of the balls. If there's one here or there out of whack, we're just going to go ahead and keep it. Now, oftentimes with the iPhone 10 data jobs, I will make a solid attempt to send them back fully repaired. But whenever they come with lots of prior rework or just overall wankery, my level of enthusiasm for sending it back entirely fixed goes way, way down. So hopefully this thing will work out. Now that we have some fresh flux on here, we're going to take the top board and sit it right back down on top of there, like so. We'll line it up nice and pretty using the microscope because it is really difficult to see these micro fine adjustments with your eyes. And it's looking pretty good. Looks really good there. Looks good all around. Now that we've got that lined up nice and pretty, we'll turn the heater on. Now once again, we're going to give this just a few moments to heat up. This thing does it pretty quick. I'm thinking maybe 5 or 10 minutes. I've got the thermostat on here set at about 215C. I'm not sure if it's actually 215. I think that may actually be a little bit hot. Almost there. It's looking pretty good. Well, I sure wish they hadn't reballed it. I much prefer Apple's factory ballage. All right, so the board heater is all the way up to temp. Now at this point in time, often I will put a small weight on top of the board because these boards typically have spacers between there that keeps the balls from smashing flat. But since this one does not have those spacers, or likely doesn't, I'm going to just I'm going to touch around on it here. We're very much molten out here. We're going to touch it right back here. That looks good. And this board looks fairly well flat all the way around, but boy, it really has some big balls. All right, let's go ahead and turn that heater off. And now we're going to let this sit here and cool down a little bit and make sure all of those balls have solidified nicely. And then we'll see if everything I did here is successful. I cannot believe I could have done this without taking the board apart. Come on, baby. Okay, this board has pretty well cooled down. It's not like cold, but it's cool enough. We're going to go ahead and remove it from the heater. And for that, I like to just kind of get a blade under it and pick it up off of there. Oh, come on. There we go. Let's go ahead and connect this up and see if it will boot. We're going to hook up our test lead. Now we're going to turn the power supply on. We're drawing 10 milliamps. That is completely acceptable. And now we're going to press the button to boot. And 1, 2, 3, boot. 100 milliamps, 150, 180. Apple logo. All right, so this board booted. Now we're going to see if we have working touch. We do. Always like to see that. Now, you know what I would really like to see next? I would like to see the correct passcode. All right, let's turn the power supply off. So to be cute, I'm just going to slip this right back in the same housing that it came out of. Like that. Now, this will be okay, provided the battery's okay. It most likely is. But on the iPhone 10, we very often wind up with liquid that seeps in, and it gets on the connector down in here for the vibrator, which causes them to boot loop and not start up properly. I'm going to take a gamble here that this one most likely does not have that problem. So we're going to connect my dock flex. Actually, take that back, connect his dock flex. We're going to use my screen assembly because I know that this is a known good screen assembly. I'm going to connect up, let's see, I've got a charged battery here, but you know, chances are this battery is most likely charged, but it's had the breaker tripped from having a dead short on the end of it. So we're just going to connect up that battery. And next, we are going to connect a charger. There we go. I suspect we'll see battery charging icon, and then very quickly after that, Apple logo. Okay, so we didn't get the charging icon, just straight to Apple logo. All right, let's let this thing start back up. I'm going to authenticate with the passcode. Okay, see if it accepts the passcode. It does. And also the battery is at about 50% charge, so it did just have a breaker trip. So now that we are authenticated, I'm going to pull up iTunes here and connect this up to run a backup. Ooh, we got USB connect. That's a good sign. I'm going to say continue on iTunes. We're going to say trust on the phone. Okay, it is alive and well. The backup encryption on this phone has actually already been set. So I'm going to go ahead, before I do anything else, I'm going to export the photos from the phone. And I'm going to do that using 3U Tools. So 3U Tools is not capturing properly with my software. So here we can see that the photos are exporting. So the photo export has completed. The next thing that I'm going to do is I'm going to go ahead and create a full backup. Now, the encryption passcode on this phone has already been set, which that is something that I can reset, but I don't like to reset the encryption passcode before I actually save an encrypted backup and also export the camera roll. So once I have the camera roll exported, we're going to go ahead and do a encrypted backup. So we're going to click. Actually, I like to uncheck this automatically sync option because we don't want that happening. Now we're going to go ahead and click backup now, and this thing is going to create a encrypted backup. If the customer doesn't know the password for that encrypted backup is completely useless. And then also I export all of the text messages, app photos and data, WhatsApp messages, as well as all of the WhatsApp attachments and message attachments. And I actually cannot do that with the backup encryption passcode set. So we'll just let this iTunes backup run until it is finished. Now, there wasn't a whole lot of photos on this phone, but it does appear to have quite a bit of documents and data, whatever that's going to be. It's probably like Photo Vault or something, right? Right? Okay, so the first encrypted backup has finished being created. So we're going to take that backup, since I don't know the encryption passcode, and we're going to kind of just move it off to the side. We're going to call it encryption password unknown, like that. And I'm going to just move this iTunes backup up there into that folder. So now we have a backup of the camera roll. We have an encrypted backup, which I do not know the passcode for. Now I'm going to move toward making a backup that is not encrypted. So to get rid of that pesky encryption passcode, we're going to go into settings and then into general. We're going to scroll down to the bottom and we're going to choose reset. Now we're going to reset all settings. We're not going to erase all content and settings. We're just going to reset all settings. Let's enter that passcode. And you can see it says this will reset all settings and your Apple Pay cards will be removed. No data or media will be deleted. So now we're going to choose reset all settings again. And here is why I typically back up the camera roll before doing this, because once in a while you'll do this reset all settings procedure and this thing will never, ever, ever start up again. Don't ask me how I know that. All right, so we're going to let this finish up. It's going to go through a series of processes here, and when it starts back up, the phone will actually not have a passcode on it, and it will not have any encryption passcode. All right, and we were back up to a startup screen. It's no longer a lock screen because there's no passcode. And now that we've made it this far, I'm going to go ahead and swipe to unlock the phone, switch back over to iTunes. And now we are going to create another backup, and this backup is going to be unencrypted and is a backup that will easily allow me to parse the data. Now, once I get the data parsed, I'm actually going to go ahead and do one more backup and set an encryption passcode, just because I like to send back an encrypted backup and then a parsed copy of the data. So the process of parsing the data, that can be pretty extensive and maybe warrants a video all by itself, so I'm not going to cover that in this video. That is pretty well it for this one. I'm going to let this backup run and finish up and then get this thing put back together. I am concerned about the screen assembly that was on this phone. The screen assemblies for Apple's so-called liquid-proof or liquid-resistant phones are actually quite prone to liquid damage. You can see that we've got a moisture indicator trip down here, and I very often wind up running into bad screen assemblies. I mean, they'll look fine, looks great, but then they won't light up. I also see that there's liquid damage up here at the top of it. They very often get the Face ID components damaged. So I sort of doubt this screen assembly works. So that is going to be it for this one, guys. I really thank you all for watching. Thanks for playing along, and thanks for sticking around. I'll see you next time. Have a good day. All right, I've got my backups created. I have an encrypted backup in which I know the passcode for. I've done a little bit of additional cleanup here next to the connector, and now we're going to find out if the screen assembly works. There's our front-facing flex. Connect our touch connector. There we are. Connect our display cable. Whoops, I missed our volume flex, I think it is. All right, let's connect a battery. And we'll connect a charger to boot in 1, 2, 3. Boot. Yay, we get an Apple logo, we got a nice broken OLED, and it looks like this customer is going to get back a semi-working phone. Oh, and I also put a passcode back on it because I don't like shipping phones back without passcodes. And we have working touch. So the phone will go back semi-working. Now, because of the liquid damage, because of all the prior wankery, I'm not going to offer to put a new screen assembly on this thing. I'm going to send this back with a flash drive that has our backups, and that's pretty well it. Thanks for watching.